Well, good morning, Chemistry 20s. I would like to talk to you today about how to calculate the concentration of a solution. So last video, we learned about what it meant to have a solution. What is a solution? Well, there's a solute that gets dissolved in a solvent, and that makes a solution. So how do we know by looking at a solution if it is dilute or if it's concentrated? Well, a dilute solution has less solute in the solution than a concentrated one. So we could tell by looking at the color. But the thing about when we're doing a calculation of concentration is this is something that is quantitative. So we see that the solution concentration is a ratio. It is just how much solute do we have divided by the amount of solution. So yes, you can look at a solution and you can tell right away which is the most concentrated and which is the most dilute. So clearly this guy is the most dilute solution. You see his color is less pink, so he has less of the particular solute, whereas this guy is going to be the most concentrated. He has more solute in the same amount of solution. So how do we express concentrations and how do we do calculations of concentrations? Well, there's a variety of different ways. So if you ever look on a package of rubbing alcohol, it says percent by volume. Others are going to say percent by weight or a weight per weight concentration. You might see maybe a glass of a bottle of wine that your parents have, and it has a particular percentage, and that is how much alcohol there is in that solution. Okay, so that is one way, a percentage, how much of the solute there is in the solution. Parts per million is another way that scientists can express a concentration. So 1 part per million is 1 drop of that substance in a full bathtub, 1 part per billion, 1 drop in a full swimming pool. 1 part per trillion is a drop in 1,000 full swimming pools. Okay, but that's not typically how scientists are going to express concentration. Scientists use the amount or the molar concentration. And for this, we are taking the number of moles, the chemical amount of the solute, divided by the liters of the solution. So the units that we're going to be using are moles per liter. That's why it's the molar concentration, something moles per liter, or because it's moles, that is an amount concentration. Sometimes you'll also see these square brackets. These here, I'm just making them bigger. That square bracket means concentration. And so the calculations are pretty straightforward. If they give you moles and they give you liters, you just take moles divided by liters and you get the amount concentration. So sometimes you might be given a mass that you have to first convert to moles and then find the concentration. So always just make sure that you're checking your units, you're checking your sig digs, and as you're doing your calculations, you are just basically following through these little communication examples. So here's an example of a weight per volume calculation, and it is grams in 100 mils. Well, then how many would be in 175 mils? It's just a ratio. Here is, I'm given concentration and I am given moles. And so I have to cancel out moles. Moles on top, moles on bottom, cancels out, and I get liters, and that's how many liters I had of the solution. So another example is where you're given the volume and the concentration, and you're asked to find the mass of a solution in grams. So how much was the original solute mass that we needed? So here is my volume times my concentration. You see that liters will cancel. I'll get moles. Once I have moles, then I can times by the molar mass of the substance that I get. It's silver nitrate. I look it up on my periodic table. I find the molar mass of silver, Ag. There's 1 nitrogen and 3 oxygens, and that gives me a molar mass of 169.88. Moles on top, moles on bottom cancel, and I end up with a mass in grams. So now at this point, when you are at your final answer, check your sig digs, go back to that original question. Oh, 3 sig digs there, 3 sig digs there, so my final answer has to have 3 sig digs. Look to see that you've got your units done. Oh, yeah, I've got units. I was asked for a mass. I know it's going to be grams. So that is how I'm going to do a calculation. So this is leading us into some solution stoich, right? If you want, you can do this all in one step, right? You started with liters and you had your volume, and the liters cancel by putting the concentration liters on the bottom. I'm multiplying them together. Now I have moles. I'm going to cancel out moles. I put moles on bottom. And what am I left with? Well, I'm left with grams. So in the following set of questions, you might be given moles, you might be given volume, you might be given concentration, you might be given mass. And so you're always going to know a couple of those different variables. And so like you'll be given 2 and have to find the third. So here's just a quick example, and we'll just run through this one. And we have seawater. And here's our concentration, 0.055 moles per liter. And we're looking for the chemical amount. So we want to find chemical amount, which is moles. And we have a volume here of seawater as well. Okay, so we're trying to find the number of moles. So we have 0.055 moles per every 1 liter. Now, if I'm looking at this question, remember that my leading zeros don't count. I only have 2 sig digs in this question. And here in my volume, I also have 2 sig digs. So reminder that my final answer is only going to have 2 sig digs. Now, I'm looking for chemical amount in moles. So that means I need to cancel out liters. So what am I going to do? I'm going to multiply by my liters, 75 liters. Liters will cancel. I punch these values into my calculator, and my calculator says 4.125. Everything is canceled but moles, so my unit here is moles. But now that's not my final answer, because remember, I can only have 2 significant digits. So my final answer, when I go and I round it, is 4.1 moles of magnesium chloride, which is in seawater. Okay, so there's an example where you have concentration and volume and you have to find moles. So another example, you might have moles and have to find concentration or volume. Or maybe first you have to go from mass in grams to moles. And remember that our unit conversion factor there is the molar mass. And we know molar mass, we use our data booklet, and that would be grams per 1 mole. And then from moles, we can go maybe to liters or maybe to concentration in moles per liter. And so we could use concentration or volume to do that. Okay, so a variety of different ways of doing this. You guys go ahead and do some practice questions, and you should be able to do unit analysis to solve these questions. All right. Have at her. And if you have any questions or concerns, michelle.ledeen@ghsd75.ca. Talk to you later.